Hey guys, welcome back. Well, we're going to try to attempt to make some upgrades on the mill today. So this original motor that used to go right here, it was a kind of, I think it was a servo, but it's basically 1 horsepower. And the way this thing was pulleyed, the maximum RPMs was 2,500 RPMs. And we're looking for more like 5,000, 6,000, 8,000, something like that. So we had this spindle. This is the one that we had on here for a while. This is 3 kilowatts. And it'll do 12,000 RPMs, but the problem is it doesn't have a lot of torque. And the bearings, this doesn't actually work good for as a spindle. So as you can see, we Mazda was nice enough to make a bolt that fits this pulley and the spindle. So I have a bolt, a few washers, our pulley slips on, got a nut to tighten all this together, and then we clamp this in a collet. So admittedly, it's not perfect. It does wobble a few thousandths, and I don't know if that'll be an issue or not. But we're going to try it, and if this works, then maybe I'll get an actual part machined that works a little better. But for now, I just want to mock it up and see how this works, because the plan is, if you look here, so this is 80 millimeters on the bottom, 60 millimeters, and then on here, this is 60 and this is 40. So if we do 40 to 80, that'll be a 2-to-1 pulley reduction. So our 12,000 spindle will give us 6,000 coming out right there, and that should be good, because that'll double the torque as well, which will be nice, because this thing does bog a little bit, especially when you put larger cutters and try to cut fast. This thing was under a lot of load, so this could work out great. So here's kind of what we're thinking. We took some measurements. If you look where my finger's pointing, this is essentially where the bottom of the spindle, this area, needs to end up at, so that these pulleys roughly land at this height. So I'll show you how we're kind of guessing and winging this. I'm actually going to try to do all this in I'm hoping to do it tonight, which is, I only got like an hour or two left, so it's not going to get done, maybe. But let me show you what we're doing. So we broke out our CAD. We've got this rectangle here. Let me show you what that is real quick. I'll just zoom over. So this is a bracket we purchased. And this has a 100 millimeter ID, and this will slip over the spindle, and it's got bolts to tighten it down. And you can see we got a flange that's not even drilled, so we can bolt this. We got to drill it, but we'll be able to bolt this. So here's the idea. As you can see, that goes right about there. That fits pretty good, and this kind of angles down to here. Let me show you what that looks like on the machine. Something like this. And then the motor would actually be on this side over here. And the reason we're doing it this way, so we'll need a plate that goes to this, that'll bolt to this, and that plate will weld to the one I just showed you in cardboard. And the cool thing is we're using the original mount here that swings. I think we're going to try to do that. If it works, it'll kind of be awesome, because then I can still tension the belt easily. And the only downside is the motor will end up hanging over here. It won't be dead lined up with the spindle. I don't know if that's an issue or not. I have seen it done that way on conversions, where people have a motor that doesn't, basically, if you put a power drawbar on one of these, you don't have much room here to even put a motor. So some guys that do big motors, or if you have a power drawbar, they'll hang the motor over on the side, one side or the other. And since we have this box over here already, we're going to put it on this side, which maybe that'll actually counter some of the weight a little bit. Who knows? But anyway, that's what we're going to do. Essentially, we're just going to rig this together. I'm going to get some steel plate for this piece of cardboard, cut that out. We're going to make one that goes here and bolt it to these 4 holes, and then just weld those two together, maybe brace it if necessary. But yeah, we're just going to throw it together. So it doesn't have to be perfect. We just need to get it, up there and find out if this is going to work. I think it will. I think it's going to be awesome. And if it is awesome and it works, and then maybe it's, we need to stiffen the bracket or whatever, we can always do that later. But I don't want to spend like 20 hours building a badass bracket, and then as soon as I turn it on, this doesn't work for some unforeseen reason. But I've done a lot of that in my life. So we're gonna get this done quick. Actually, I planned to do this tomorrow, and we just started on it today. So I'll bring y'all back when we make a little more progress. Well guys, we stayed up late. Man, I actually got off work today at like 5:30, 6 o'clock. It's a little after midnight now. Look what we did in about 6 hours. This isn't finished. But we actually kind of pulled this off. We got our 3 kW spindle, we got our bracket, we built this plate, that one we showed out of cardboard, we cut it out of steel. We did the same thing for that plate, made it out of cardboard and then made it out of steel. So this is like a flange that here, and then this is the one that moves, and this bolts to that, and then this plate is the one I made that bolts to the original. And I can't get my camera under here, but there's actually socket head screws under there that are like countersunk and everything. And it's out of focus. There's one. Kind of crazy. That actually worked out pretty good. So anyway, yeah, so this isn't finished though. We had watch, I'll try to show you. I'm gonna push up here. Oh, it doesn't really show. Anyway, this is wobbly. Yeah, you can kind of see it that way. Flimsy, but I just wanted to throw it up there and see if I got it right. So you can see our belt tight's pretty good, which here, you just loosen this clamp, you can move the spindle up and down. And the way this thing pivots, there's a pivot here, and this bolt swings, so that's how you tension it. And it's actually fairly perpendicular if you kind of back up, and it's kind of hard to judge, but I mean, it's pretty much straight up and down. It's close, it's just a belt, so if it's off a degree or two, it really doesn't matter. But yeah, and check this out. Here's the big one. So our speed override's at 5200, and I have a tachometer. So we're commanding 52, we're getting 48. And over here we should have half of 48, which is 20, roughly 25. Roughly a 2-to-1 gear reduction. So we call out 52, we get 25. That's about 2-to-1, it's close. But this works. Now it is vibrating a little bit, which is kind of expected. I think in the long run I'm going to have to remake this piece or get it machined properly, because I just literally put a bolt. So it does vibrate some. And of course I think this will vibrate a little as well. But anyway, holy crap, we did all this in a day. I still got to work on it, but like, watch this. Look at that. Over 25. 48. 5. There's all of it. That's 12K on the spindle. It's actually right at $6,000 on the output. So it looks like 2-to-1's working there. I'm gonna slow it back down because I don't have the water cooling hooked up right now. I don't want to overheat my spindle. So how about that? And man, this is going to be, hopefully this works out, but we should have so much more torque now than we used to because of that 2-to-1 reduction. So man, that ought to make all the difference in the world. Yeah, you may have just seen it shake a little when it turned off. So definitely got to work on the balance part. But it doesn't have to be balanced to see if this even works. And if it works, then great. We'll see, I don't know how low this would go. It's 400. Anyway, you can kind of see a little bit of, maybe you can see a wobble there. It ain't much, but you know how it is. High RPMs, it'll get you. But yeah, so basically we're going to finish this tomorrow because it's after midnight. But it looks like what we got to do, we got to get some bracing from here to here to stiffen this up. Because like I said, if you hit this, yeah, you can kind of see it there. It flexes. So we'll build some kind of bracing that kind of ties from this plate and reaches up here. Something here, something there. I don't know. We'll figure that out when I'm got some sleep and energy. But man, kicking off the weekend in style. This is some damn good I was expecting, I would have been happy if I accomplished this by the end of the weekend, and we did this on Friday night. So man, it's going to be a good week. All right, y'all take it easy.